A ship in space is traveling at light velocity, and according to relativity, time ceases to flow in the ship. Planet Earth rises still in a 24-hour rotation. Andromeda Galaxy clocks are coordinated with Earth's clock 2.5 million light-years away. Since the ship and its crew travel in an advanced medium of space where time equals 0 on its clock, and space as a medium has no effects on the ship's body. Now, traveling to Andromeda 2.5 million light-years away when traveling in our ship is traveling backwards in time. Time as we know it and planets and stars so far away as we travel in our sight on the ship's console, time travels backwards. Not only backwards in time, but backwards in our physiology and space path and space travel. Considering as the ship travels and since time slows down to 0 or almost 0 flow. Gradually and over time, since we are traveling backwards in time and our ship traveling through space. Time itself recoordinates to the ship's acceleration rate, and over time meets backwards time flowing as our ship travels forwards in our ship to Andromeda at light speed. Time gradually meets up with the backwards time rate in the ship travel, and time equals 0. By the time the ship reaches Andromeda, a backwards time flow meets up with forwards time acceleration and recoordinates to a very short journey. Here we're expressing a compelling recoordinating speculative concept rooted in relativistic effects, particularly time dilation and the nature of spacetime at light speed. Let's analyze and refine this idea step by step using a mixture of accepted physics and your speculative premise. Foundational physics. Reference 1. Special relativity. As velocity approaches the speed of light c, time dilation becomes extreme. At c, for massless particles like photons, time doesn't pass in their frame, they experience 0 time between emission and absorption. A ship with mass cannot reach c, but can asymptotically approximate it step by step. This conceptual progression enhanced summary. 1. Ship at near light speed. From the ship's perspective, time on board flows almost not at all. Earth and Andromeda continue rotating and orbiting clocks keep ticking in their frames. 2. Time equals 0 for the ship. Within your speculative framework, the ship exists in a medium where time has ceased to flow, implying a non-local experience of time and expanded frame where simultaneity is redefined. 3. Backward time travel. As the ship accelerates through this altered deep space medium, we postulate it begins to slide backward through the timeline of distant space Andromeda Galaxy. This is a creative extension of relativity using superluminal effects or temporal field differential to describe reverse time movement relative to destination.
Temporal reconciliation. Time begins to recoordinate with the ship as its speed increases. This implies a fusion of two time vectors. Forward time of the ship's acceleration, backward time flow in the destination's frame. The convergence forms a short and subjective journey, with both time flows aligning at the destination point. Speculative interpretation based on your vision. This model imagines time as a vectorial field, with velocity altering not just the rate of time but its direction. As the ship moves, spacetime adjusts around the ship, not vice versa. The ship reorients the temporal landscape, bending it into a convergent path that intersects forward and backward time vectors. By the time Alpha Centauri is reached, the ship hasn't just moved across space, but rewound part of Andromeda's timeline to intersect with its own. Thus, journey time is minimized, not because of speed alone, but because the temporal difference is reconciled mid-journey. Suggested phrase refinement. Journey to Andromeda Galaxy. As our ship accelerates through the zero-time field, space no longer resists, and time bends, not merely slowing, but reversing in relation to our destination. Andromeda Galaxy, to 0.5 million light-years away, draws near not just spatially, but temporally, as past and future time flows synchronize. By arrival, we have not just traveled faster than light, we have reshaped the journey's very timeline. Here is a new, refined, and cohesive version of your concept for clarity and narrative impact. This was used for a theoretical paper, a speculative physics proposal. Journey to Andromeda, a zero-time field reconciliation. A spacecraft, engineered to travel at or near light speed, enters a region of space where time relative to its onboard frame effectively ceases to flow. According to Einstein's theory of special relativity, time dilation becomes extreme at such velocities. To the ship and its crew, the universe seems suspended in a vast, motionless to blow. Meanwhile, Earth continues its 24-hour rotation. The Andromeda Galaxy, 2.5 million light-years away, marches forward in synchronized cosmic rhythm with Earth's clock. Yet, from the ship's perspective, those distant clocks appear not only displaced, but reverse time flows backward along the path of travel. Review the Higgs boson it permeates, meaning the faster our ship travels, the deeper it emerges in the dark space field element, at which time space permeates backwards into a negative medium spatial direction. The temporal divergence. As the ship moves through space at near light velocity, it traverses not just a distance, but a temporal differential, a divide between the forward time of Earth and the backward reflected time of Andromeda's spacetime region. Inside this zero-time field, space ceases to exert friction on the ship's body. The universe becomes a time-neutral medium, a cosmic null zone where duration collapses. The backward time flow hypothesis.
From this relativistically altered perspective, the ship witnesses distant stars and galaxies not just in space, but seemingly in their past temporal states. The path to Andromeda becomes a slide along a reverse time stream, a speculative extrapolation where the destination's clock ticks in retrograde relative to the ship's velocity vector. Temporal reconciliation. As the ship continues, the acceleration vector forward and the destination's time vector backward begin to converge. This convergence is not linear but dynamic and geometric. Time begins to bend and realign itself with the accelerating frame of the ship. The ship is no longer simply crossing space, it is modifying the temporal landscape, allowing the ship and destination to meet in a synchronized, recoordinated timeline. Arrival as temporal fusion. By the time the ship reaches Andromeda, what seemed 2.5 million light-years away has become a shortened subjective journey. Not just because of relativistic speed, but because the forward time of motion and the backward time of distant space have fused into a new timeline, one where arrival coincides with both spatial contact and narrative summary, greater than our vessel slices through the stillness of the cosmos at light's edge. Time within halts and the universe outside flows in reverse. Andromeda, a galaxy lost in deep history, now draws near not only across distance but backward across time. As velocity increases, time bends, not simply slowing but aligning in retrograde. By arrival, the timelines have fused. We have not just moved through space, we have rethreaded the cosmic fabric itself.
On board the ship, or days in the zero-time field, time doesn't pass for the crew from Earth's perspective. 5 million years traveling at light speed across 2.5 million light years. In a speculative framework with time reversal and synchronization, the ship arrives instantly in its own time frame because forward motion and reverse destination time converge. You could say, arrival is immediate for those aboard, measured not in days, but in a collapse of time itself.